What are the odds? I mean, it's a question we ask ourselves all the time, right? Well, today we're going to pull back the curtain on the language of chance. We're going to take all that uncertainty and turn it into something we can actually measure. So let's just dive right in. So think about it. How do we even begin to measure something that hasn't happened yet? I mean, we are surrounded by uncertainty, right? From what the weather is going to do tomorrow to how the stock market will behave. The answer, it turns out, is probability. It's basically a language of numbers that lets us make sense of all that unknown stuff. And look, it all starts with something super, super simple. A basic coin toss. That's it. It's pretty much the purest form of chance you can get, with just two ways it can land. This is our first building block. And here's the really cool part. What's amazing is how this one simple idea can scale up. I mean, way up. From that single coin flip, we can actually build a whole framework to understand the much, much more complex odds we're dealing with every single day. So that's exactly what we're going to do here. We're going to build your mental toolkit. The goal is that by the end of this, you'll have the core concepts you need to think way more clearly about chance and probability in the world all around you. All right, so first things first, let's ground all this in reality. We all have things we worry about, right? But how do you actually put a number on a feeling? Is that even possible? Well, a Gallup poll asked a question just like that. It's something super personal, something a lot of us can relate to. So let's see what the data actually showed. And here it is. The poll found that 45% of American adults worry about their weight. And just like that, a vague general feeling becomes a hard, concrete number. That is the power of probability in action. It gives us a way to quantify our world. Okay, so to get to a number like that 45%, you can't just guess. You first have to map out every single possibility. This is the absolute foundation of probability, so let's walk through a few key terms we're going to need. First up is the word experiment. Now, in probability, this doesn't mean you need lab coats and beakers or anything like that. Nope. It's just any process that has an uncertain result. So, tossing a coin, that's a perfect example of an experiment. Okay, so each possible result of that experiment is what we call an outcome. So for our coin toss, the outcomes are pretty simple, right? You either get heads or you get tails. That's it. And when you take all of those possible outcomes and group them together, you get what's called the sample space. For one coin toss, the sample space is just heads and tails. Super simple. Now, let's kick it up a notch with a slightly more complex example. So here's the same idea, but with a different experiment. Let's say we're selecting two workers at random. The sample space here lists out every single possible combination you could get. And this is so important because you have to know the entire sample space, this whole map of possibilities, before you can even start to calculate any odds. Okay, great. So we've mapped out all the possibilities. Now for the fun part. Let's attach some numbers to them. How do we actually calculate the probability of something happening? This right here is the classic formula. And honestly, it's wonderfully simple. The probability of something happening is just the number of ways you can get the result you're looking for, divided by the total number of things that could possibly happen. That's really it. Let's make this super concrete. Imagine a standard six-sided die. What are the chances we roll an even number? We can use that formula we just saw to figure this out exactly.
Okay, let's walk through it. So first, what are our favorable outcomes? Well, we want an even number, so that's a 2, a 4, or a 6. That gives us 3 possibilities. Then, what are the total possible outcomes? Well, you can roll a 1, 2, 3, 4, 5, or 6, so that's 6 total possibilities. So now we just divide. It's our 3 favorable outcomes divided by the 6 total outcomes, which gives us 0.50, or, a 50% chance.
Okay, that's pretty straightforward. But in the real world, things aren't always that simple, are they? Events are often connected, where the outcome of one thing can totally change the odds of another. And this is where it gets really, really interesting. What we're talking about is called conditional probability. And the absolute key word to remember here is given. We're asking a very specific question: what's the probability of event A happening given that we already know event B has happened? And that little vertical line you see in the notation, that's just shorthand for the word given. Let's see this in action because it'll make more sense with a real example. Check out this table. It shows data from a survey of 100 employees, and it's broken down by their gender and their opinions on CEO salaries. This has all the ingredients we need to ask one of those conditional questions. Okay, so here's our question. We are not looking at all 100 employees anymore. That little phrase, given they are male, that's the key. It completely narrows our focus. So how does that change the math? Well, because we're given that the employee is male, our entire world shrinks. We completely ignore all the female employees and focus only on the 60 men from the table. Now, out of those 60, the table tells us that 15 of them were in favor. So you take that 15, divide it by our new, smaller total of 60, and you get 0.25. See that? The condition completely changed the odds.
All right, and let's touch on one last key idea here. It's the difference between two types of events. On one side, you have mutually exclusive events. A super easy way to think about this is rolling an even number and an odd number with one roll of a die. It's impossible, right? They can't happen at the same time. There's zero overlap. But then, on the other side, you have events that are not mutually exclusive. For instance, can you roll a number that's both even and less than 5? Yep, if you roll a 2 or a 4. Because those can happen at the same time, there's an overlap.
So, okay, we've built up this little toolkit of ideas. But why does any of this actually matter? Well, it matters because even though probability can't perfectly predict the future, what it does do is give us a really powerful logical way to think about and navigate all the uncertainty out there. So I'll leave you with this to think about. Whether you're considering a big career change, making a financial investment, or even something as simple as planning your daily commute, how could thinking in terms of probabilities, weighing the odds, mapping out the possibilities, how could that change your next big decision?